Hello, everybody. Welcome on in. I shared these parts on Discord a little while ago, and I got some questions about how I made them because they're so damn small. And I thought it was kind of special because they're made in one operation, a single setup, which I think is pretty cool. Today we're going to take you through how I did it. In case you don't know, these pins are the yellow part in the center of my tiny little cycloidal gearbox that I'm in the process of building. The full CAD is on the top right, in case you forget what we're doing. But this is the eccentric shaft that drives the whole thing. The gearbox itself is a 20 millimeter hex, and so it's quite small. It's been a challenge, but it's been a lot of fun along the way too. While you were not looking, I took the liberty of roughing in our pin and drilling and tapping the hole. Excuse me, drilling and reaming, not drilling and tapping. The hole in the center, because I don't trust it to run that without flood coolant. And so for the rest of this, I have taken the liberty of disabling all of the safety systems on the machine. Instead of running flood coolant, we are going to be running with a bottle of WD-40 and an air gun, which should be fine. But so next, we've got it roughed in because this is not the you missed all the boring parts. It's not very interesting. Now the special part comes right now. So we're going to pull up our tool, because the way that I did this was with a T-slot cutter, which is coming in right now. So this guy has a reduced neck. Just going to give it a little bit of juice. So this is going to come in and rough the lower bearing surface here. And so it has a reduced neck here and a larger cutting diameter so that it's able to reach around shoulders like this. And also, I apologize for the lower camera quality. This is as close as I'm willing to get my tripod to it, and really as close as I'm able to get to it. So I have to zoom in with my phone. It is what it is. So there's that. And next up, the other special part of this operation is the chamfering tool. So let me get this in frame, and then we'll pause and take a look at it. So as you can see here, just paused it. As you can see here, that instead of just a single angled like you would see for a normal chamfer mill, this has the angle going in both directions, and so it's able to do both the top side and the underside of a part at once, which you'll see right now. So right now it's doing the top edge, chamfering that, and now let's see, it's going to do the top edge of the shoulder. Just like that. Just gonna get a little squirt. And then now we're going to do the underside of it. Just like so. And now the interesting one is the bottom edge, because that one I have to cut into the stock quite a bit to make it work. As you can see right here. And now you'll notice that I said that we were roughing the underside, and that this is all just roughed out. And that's because this chamfer tool is not exactly the sharpest tool in the shed. Somebody once told me, anyway, so this guy kicks up a little bit of a burr, and it's extremely difficult to deburr something this small without just ruining the rest of the surfaces. And so I'm chamfering them first, and then coming in and finishing them, which we're doing right now. We're going to finish the middle section right here. And so any burrs that are created by this will just go into the chamfer and not into the actual, and not actually cause problems with the rest of the part. So right now we're finishing the middle we're finishing the middle section. And the reason that I'm doing it like this is because it's impossible to measure the underside, the bottom bearing surface, as it stands, because it's just so damn small. It's too close to the rest of the stock. You can't get a micrometer on there. I tried measuring it with between two gauge pins. Didn't really give me good results. And so instead, what I'm doing is we're finishing this middle section and the bottom section with the same tool. And so in theory, that will give us, it'll have the same amount of offset. It'll be the same amount wrong, if that makes sense. And so that means that I'm able to just measure the middle section, which is, therefore know what the the bottom section is, the dimensions of that. So that's almost done here. You can see it gets an extremely small neck towards the center. Yeah, sorry this is so crusty. You know, you can pretend like it's 2012 and this is perfectly acceptable video footage. Alright, so next up we're going to finish the upper bearing surface, I should say. I should say these are not the actual bearing surfaces themselves. These are surfaces where bearings sit. I decided to use real ball bearings here because this is the high-speed input section. But it's made out of bronze for convenience, and because that means I can easily silver solder it to the shaft if I so choose. Now this is the next cool part of this step. We're going to be parting it off. This is the real magic of this. So we're going to be coming in with this saw and just cutting it away, just like so. It's going to come in, just make it a line all the way around. Make sure it's got lots of juice on it. It's just slowly making its way around. Honestly, you could probably make it faster, but I don't want to push my luck. I've had several of these break. Not on this part, but same thing. Alright, and now it's done. So now, all I have to do, and as a reminder for how insanely small these are, here's a piece of rice, a single grain of white rice, uncooked. So there's that. And now we can come in, and all that I do to take it off is put a piece of, I put my thumb over the pliers so that the part doesn't come out, but I just use the wire cutters to cut the excess stock away. Just like this. And let's see. And there's our part in all of its tiny, tiny glory. It still needs to be deburred on that backside, but I think that's a worthy sacrifice to not having to make it in 2 operations. So, hope you all have a good day. Thanks for watching.